Let's talk about Project 3, Lesson 15. The table shows data that were collected on a hot air balloon. Which function f of x best models the data? And you're given some multiple choice options. So some things to consider as you're trying to model this function. Now remember, we're pulling data from this table which describes the balloon's height in meters and the distance that you can see this balloon. So x, remember, is always our independent variable. F of x is our dependent variable. So the first thing you need to do is figure out which one of these is x and which one of these is f of x. Is the balloon's height the independent variable or the dependent variable? So think about it. Ask yourself, does the balloon's height depend on the distance you can see? Or does the distance you can see depend on the balloon's height? Again, does the balloon's height depend on the distance you can see, or does the distance you can see depend on the balloon's height? So think that over, and once you figure that out, you'll be able to decide which one is the independent variable and which one is the dependent variable. Your independent variable, of course, is x, and your dependent variable will be f of x. From there, take a look at the options they give you. I really want you to just play around with them, be organic. There's no particular way you need to approach this. You can use the data from the table to kind of help test your theory about which function is correct. If you're in a hot air balloon at a height of 100 meters, you can expect to see how many kilometers? Round your answer to the nearest kilometer and enter only the number. Okay. The way this is phrased, students often think they're being asked to simply say, okay, well, the balloon's at a height of 100 meters, and then they see kilometers, and their first instinct is just to take 100 meters and convert it to kilometers. If you're doing that, you're not reading the question very carefully, okay? Don't skim these questions. So this is describing a height that we're at, right? So we have this hot air balloon, little basket, little guy in it, okay? We have this hot air balloon that's at a height of 100 meters. And we want to know how far that this guy is going to be able to see. Okay? How far out is he going to be able to see? So, yes, these two are related, but in no way are they the same number. Okay? So, based on the function from the last question, which described the relationship between the height of the balloon and how far you can see visually, well, now we've been given a number. We've been given 100 as our height. So I should just be able to plug 100 meters into my function, and it's going to tell me immediately how many kilometers I can see from the balloon.